Jai Hind everyone. My name is Anushka Tyagi and I am assistant professor at IT department at Akgec. Today my topic will be on introduction to computer networks. So first of all, when we study about computer network, so first we have to learn about telecommunication and data communication. So what is telecommunication? Telecommunication means that we can communicate between two devices at a distance. Like if the sender and receiver are at a distance, then we will communicate with each other. This is known as telecommunication. And the data telecommunication, we exchange the data from sender to receiver at a distance through a particular link. That link can be wireless, wired, and anything else. So here is the telecommunication and data communication. Now, in the data communication, we have particularly 4 components. First is delivery, like how our data is delivered from sender to receiver. So my data must be delivered to a correct destination. Like if I am sending a mail, to someone, so my mail must be received by the receiver, like whom I have mentioned in my sender email. Next point is accuracy. My system must deliver the data accurately. No data should be missed. No loss of data. No manipulation of data is to be done. My data should be accurate from the sender to receiver. Now we have some timelines there. Like if I'm sending my data on a particular time, that and the receiver must receive the data at some particular time. So no lagging will be there, no disturbance will be there in between the sender and receiver. Now 4th point is jitter. Sometimes we can see that if we are doing the video call, sometimes the video call get paused, like video call get freeze. So this is known as lag. Like video packets are not loading at the speed of for a receiver to receive the correct message. So this jitter, there is a lag. For example, as we have learned, for example in the video get freeze, and we won't be able to see each other. So these are the main fundamental characteristics of the data communication. Now as we can see, we have 5 components in data communication: message, medium, sender, receiver, and protocols. Sender, who is sending the message through a medium, like we have link. Medium should be wired, wireless, like in a LAN cable, Wi-Fi, etc. Receiver, who receives the message, like in the message the data we are transferring from sender to receiver. And there are some protocols. These protocols are some rules, like we have set for the communication between two devices. Now here are the 5 components of data communication. First is message. Message is the information to be communicated. The data should be transferred. For example, data can be in any form, like text, number, pictures, audios, videos, PDF, documents, anything. So this is the message. Now the sender is the device that sends the data message. It can be anyone, like telephone, headset, video camera, computer. Like if we are sending some message on a messaging app, so the messaging app is the sender. Like we are sending some message through a video call. So through a video call we can send a message. So this is the sender example. Now receiver, we can receive the data. We can receive the data as a receiver. It can be computer. It can be also computer, telephone, handset, television, workstation, etc. Transmission medium, as I have also discussed, the transmission medium is the physical path by which the data is transferring from sender to receiver. The message is traveling from sender to receiver. It can be in any form, like cable form, wired, wireless, Wi-Fi, LAN cables, etc. Now the protocols. Protocols are some rules that are assigned to the that are assigned to the communication, like we can communicate with each other easily. Sometimes we have multiple manufacturers, multiple devices like computer, phones, TV, etc. So we have to come on a common ground to communicate with each other. So we set some rules, we set some protocols, so we can communicate easily without any tension, without checking that this is the manufacturer is different, the data, the receiver, like I am sending a message from a keyboard to monitor, so both devices are different. So we have to come on a common ground. We created some protocols and rules so we can communicate smoothly with each other without the obligation of devices and anything else. So data in data representation, we have mainly 4 types of data representation: text, which represents the data in bit pattern; numbers, which also represents in a bit pattern; audio, we refer by the recording and with the sounds and music; video refers to the recording of a picture and a movie. So here we have the data flow. Data flow is of 3 types: simplex, half duplex, full duplex. As we can see in simplex model, we have the mainframe, then we have the direction of the data and monitor. The direction of data will be one directional, like we are sending a data from mainframe to monitor. For example, we have keyboard and monitor. Keyboard will be the mainframe, then it will send some message, like we are writing some message, so it will display on the monitor, it will show on the monitor. And next example is OTP messages. When we apply for OTP messages, the mainframe, the company or whatever, the server releases the OTP that appears on our phone screen. So it is a one-way communication only. We receive the OTP, we receive the OTP, then the conversation is blocked. So you cannot send another message back. Okay. Then we have the half duplex data flow. Here we have the two stations, we have 2 devices here. So here as we can see, direction of our data at time 1 and direction of our data at time 2. We are not communicating at the same time. We are sending some message, then it will appear on station 2, then we will receive some message. For example, best example is a walkie-talkie. In walkie-talkie, we press a button, then we speak our message, then it will get received on a receiver's end, then it will press a button, then it will send the message back again to a sender. So this is how it works. We can send our data in one direction at a time only. Then we receive the data, and so on. Now next is the full duplex. In full duplex, we have the direction of data all the time. We have 2 stations and the data is transferring from one station to another at the same time only. For the best example of this full duplex is video calls and phone calls. In video calls, we are seeing each other at same time. We are speaking to each other at the same time. Same on phone call, we are sending and receiving the data same time. We are giving the data, then we are receiving the data at the same time. So the direction of data is all the time. We are sending and receiving the data to each other at the same time. Now we have the networks. As we have read, computer networks, the second term is networks. So networks are the set of devices. Here we are adding a new term, nodes. All the devices, all the stations, sender, receivers are come into a term under the term nodes. So I will refer these devices as a node in next some slides. So be prepared. Now these nodes are connected through a link where the data can be transmitted. We have one node, we have second node. The links will be like we are sending the data from one node to another. The link will be created. This is a transmission medium, it can be wireless, it can be wired, anything. The node can be here, as you can see, a node can be of any a computer, printer, any device which can be capable of sending or receiving the data. So in network criteria, we have particularly 3 most important rules: performance, reliability, and security. So in networks, we have first option, we have is first criteria we have is performance. In performance can be measured in two types: transit time and response time. Transit time is the amount of time which is the message is taking from travel to one destination to another, one device to another. Like it will check like if the transit time is good, and then response time is between the inquiry and a response time. So number of in transmission medium we check like if my data or if any message is transferring from one from sender to receiver from one node to another is correct or not. Then we have the reliability, like we have to check like if the link we are sending, if sometime it fails, so it will recover on its own or not. The network must be robust, must be strong, like it can recover from that failed link. Then we have the security issues. First of all, we have learned that the data is the most important thing on computer network. So we have created some protocols, and right, like we don't want to lose the data, manipulate the data, or miss the data, or corrupt the data. So every time we are doing something, so we at last our result will be like we don't want to lose the data. So in security, it will protect the data from unauthorized access, protecting data from damage and development. It includes some policies and procedure for the recovery of the data if my data losses. Now we have two types of connection: point to point and multi point. Here we have two stations and two nodes. They are connected with a link. Link can be link is the area where the data is transmitting from one point to another. So the two stations are connected to each other only. In multi-point, we have some mainframe. The data is coming from a mainframe. It can be anything, server or anything. Then in a link, the multiple stations are connected to each other from some point. So this is the multi-point. Now the data is transferring from nodes to nodes, from devices to devices. So there is a term which refers to the network which laid out physically, like how the devices are communicated. So here the term comes topology. If two or more devices are connected to a link, then it forms a topology. If a network contains two or more devices, then a topology will be formed. It is the geometric representation of relationship between the links and linking device. So in topologies, in computer network, we have four types of topologies: mesh, star, bus, ring. First of all, we have the fully connected mesh topology. In this, as you can see, we have 5 stations which are interconnected to each other. In mesh topology, all the devices, all the nodes are connected to each other. Each node can send or receive data from other nodes which are present in the mesh topology. We have some advantages and disadvantages. Everything in the world have some advantages and disadvantages. Advantages of this: dedicated link guarantees. Mesh topology is robust, like it is very strong. Privacy or security, we obviously, if we are sending a message to directly from node to a node, so the privacy will be good. The point to point links make fault identification and fault isolation easy. We can easily check if there is some fault, like we know, like if this node is sending data to this node, and the data will get corrupt, so we can check like, okay, we receive the data from this node, so we can check and we can correct it. Now disadvantages: amount of cabling and number of input ports are required. Like the data if there are many nodes are connected to each other, so there will be cables, there will be many ports, input output ports. So installation and reconnection also difficult. If the sheer bulk of wiring can be greater than available space, if we have small space, then this will be a bit difficult. An example of this mesh topology is telephone regional offices. Now next topology, we have hub, we have stars. In star, as you can see, we have a hub and the nodes are connected to a hub. we have a mainframe which is which are connected to other stations or other nodes. So we are receiving a data from a hub. If this station have to receive some data, the hub will send to this particular station. If this station wants to receive some data, then hub will particularly send the data to direct this station. So in this, it is advantages, like it is the device in this, if the advantages is like the devices are not directly linked to each other, so there will be no confusion, like which devices is getting the connected, which devices is getting data from which device. We know the data we are receiving from a particular mainframe, particular hub, so we know the source of the destination. In the advantages, it is less expensive than mesh topology. Obviously less devices are less wiring will be used, so less expensive than mesh topology, easy to install and reconfigure. Robustness, yes, is strong. Fault identification and fault isolation is easy. We can easily check like if there is any error, so we know like we receive the data from hub, so we know like the data come from there is incorrect, so we can easily correct it. The dependency of whole so disadvantages is here is the dependency of the whole topology is on single point. Like if hub goes down, then everything goes down. So this is the main and most important disadvantages of this star topology. An example of this topology is LAN networks. So next is bus topology. As you can see, in bus topology, we have a cable, then these nodes are connected to that cable only. So the nodes are connected to a cable at a point which named as tap. And the link between the nodes and the cable is known as drop line. So the bus topology is multi-point. One long cable act as a backbone for all the devices. Then if we are sending some message, from a cable end to the last station, to a last node, so the message will come, then it will go through first station, then it will check, no, this is not my receiver, then it will go to next, then it will check from this, and then it will go for the final receiver. Then it will go to the final receiver and get the receive. So as here the signal travels along the backbone again and again, so the energy is transformed into a heat. Therefore the message will become weaker and weaker. So there is a reason, like we can use only number of taps, we can use only limit number of taps only, we can use only some stations here. We cannot add many stations, many nodes here, so we have to limit our stations. Advantages, like it is easy to install. Backbone cable can be laid along the most efficient part, then connected to the nodes by drop lines by various lengths. As we have seen, drop line is the link between the cable and these nodes. Now in star, we know we need a one room only. Like we have a hub there, then we are connected to the computers. But in bus topology, we only need a cable. We need only long cable. Then we can connect different nodes to each other. And here these are the disadvantages of this. Difficult to reconnection, because if this device got defected, then this cable and this we have to reinstall again. Like we have to install again all the cable line will not work. Okay, difficult to add new devices. Obviously, like if the message is going again and again, the heat is producing, the message is getting weaker and weaker, so we will avoid to add a new device. So a fault or break in the cable stops all the transmission. If there is a fault in a cable line, then all the transmission get busted, all the networks will not work. Example of this is Ethernet. Now we have the ring topology. In this ring topology, as we can see, it is connecting the 6 stations to each other. The data is unidirectional. If we are sending some data, then it will go through this. Like the data will be in unidirection only. Okay, it is then the stations are connected to a data. We have the repeater. It will repeat the data from here and here. Then it goes. Now here the some advantages. It is easy to install and configure. Each device is linked to only its immediate neighbor, only like point to point with each other, point to point with each other neighbors only. Now we can easily add new connection, because we have to connect with only, we have to change only 2 nodes. If I want to add some new node here, so I have to change only this and this node. I don't have to change the all topology in all stations. So I can change between the two only. So the disadvantages of this is here we have the unidirectional traffic. In a simple ring, a break in a ring can disable the network, because the data is traveling unidirectional. If one node is not working, one station is not working, then the data flow got disrupted, and the ring topology, all the data will not transfer from one place to another. Then this topology will be busted. Here is the hybrid topology, a star backbone. We have the star backbone hub, and we have the star backbone. Then we have these 3 buses network. This type of network, the hybrid networks works in our industry, in a different ways. So these are some topologies in which our these are some topologies in which our networks communicate with each other, and they will create a path from sender to receiver. Like we can easily communicate, and we can easily send data from sender to receiver.